Hello ladies, so today we are working on section 5.3, which is the tangent function. So up to this point we've worked with the sine and cosine function and graphing it, and now we're just going to look at the tangent function. We're not really going to do anything super special with this function. There's no plus or minus C and D or A and B, all that kind of stuff. We're just going to simply look at just tangent itself and look into some word problems dealing with the tangent function. So first we're going to start off, we're going to look at some characteristics by graphing it. So I have a little table of values here. So what we're going to start, we can graph here is, we're going to start off with x being 0. Then we'll let x equal pi over 4. Then we'll let x equal pi over 2. Then we'll go 3 pi over 4, and then we'll do pi, and 5 pi over 2. So you're going to plug those values into your calculator and you're going to find your y value for this tangent function. So if you guys want to, take a quick second to pause the video and we'll find out what these values here are, and we'll look at how the graph looks. So take a minute to pause, try working out this equation with your calculators. If I give you your first one here will be 0, your next one will be 1, and you guys can work the rest through here. If you do get errors, if you ladies recall that means that that value is undefined at whatever you let your x value be. So you will see that a couple of times, and we'll discuss briefly about what undefined means. So take a minute or two, pause the video and try filling out the rest of this table. And even then, try going on to a few more values like 3 pi over 2, or even go into negative pi over 4. It'll help you see a little bit more of the shape of the graph as well. But the tangent function is pretty straightforward. It does the exact same thing over this. It's a repeat. It's periodic, so it'll do the same thing after so far. So take a quick second to pause it, and we'll get to it. Alright ladies, so hopefully you had a chance to figure that out, try graphing it yourself. So here's our table of values here, so I just kind of filled the rest in. So when x is equal to pi over 2, the value there is undefined. And if you ladies remember what happens when a value is undefined, that means that we have an asymptote, and that is basically at those points, your graph will never ever touch those points. So when you're at x is equal to pi over 2, that's kind of somewhere around here-ish. Your graph could get very close to it, but it will never ever touch pi over 2. Alright, so now let's look at maybe some characteristics of the tangent graph here. So first we could say the period here is, this one's pi, so that's different from your sine and cosine, where your sine and cosine functions, they had a period of 2 pi. This one, if you notice here, it is only 1 pi, and actually if we were to continue on to say 3 pi over 2, this one here would be undefined. So if you take the difference of pi over 2 and 3 pi over 2, it would be 1 pi. So we could say that our period here is 1 pi. The graph, it has no maximum and has no minimum, because you notice that your y values keep going up and up and up and they don't stop. So our graph has no maximum and no minimum. So with that said, our range will be equal to y is an element of all real numbers. Your vertical asymptotes, they occur at x is equal to pi over 2. If we want to do a general one, we're going to say plus n pi. And that is also where n is an element of integers. Alright, so next we can go into our domain, and our domain once again will be different from our sine and cosine, especially because we have these vertical asymptotes here. So our domain is going to be x cannot equal to any place where these vertical asymptotes occur, so we can just basically repeat what we said. So x cannot equal pi over 2 plus n pi, where x is an element of all real numbers, and n must also be an element of integers. So next we can look at the x-intercepts, and we could do this, if you guys did your graph, hopefully when you made them, your units should be in pi. Unfortunately the graph here that I have isn't, but you should notice the pattern that every time you add a pi starting at your origin or take away pi, you should notice that there will be an x-intercept at those points. So we can make a generalized formula, or I guess little written notation for our x-intercepts. So they occur at when x is equal to pi times n. And this is where n is an element of integers. So kind of nice that way. So we can also talk about the y-intercept. This one only happens once, and that is when that is at your origin. So you can say that is at when it's equal to 0, or you could also write the coordinates 0, 0. Cool stuff. So one thing that I guess there's two questions that I can ask you now. Is this graph continuous? So looking here, remember that continuous, it should never ever cut off. So this graph is not continuous because it has vertical asymptotes. And also, can we have an amplitude for this? And the answer for that one is no, because if you remember that the amplitude, it is your max minus your min all divided by 2, and because we don't have our max or a min, that's why we can't have an amplitude. Alright, so that's about it that I have for my characteristics of the tangent function. So now we'll quickly do an example. Here we have a wonderful word problem. Your homework is pretty much, well, there's only 3 questions and it's pretty much word problems. So, and they're a little bit tricky, so hopefully this question here will help you when completing the homework. So let's just jump into it. All right. So this example, an airplane is flying at a constant altitude of 6,000 meters directly toward an observer. Assume that the ground is flat in the region close to the observer. So part A is determine the relationship between the horizontal distance in meters from the observer to the, that should say plane. Wow, let's learn how to type here. I think I need to retake English. So from the observer to the plane, and the angle in degrees formed from the vertical to the plane. B is to sketch the function. C, where are the asymptotes located in this graph? What do they represent? And finally, D, explain what happens when the angle is equal to 0. So to get a better picture of what this whole, I guess, word problem is saying, I'm just going to pull out my handy dandy paint here. And I just want to draw maybe a picture of a triangle. So let me pull out here. So basically what this one here is saying is that we have an observer, say he is right where my mouse is right now, and there is a horizontal distance, and our question said that it was 6,000 meters. Don't judge, I can write nicely. Alright, so it had a vertical height of 6,000 meters, and your plane is, say, somewhere over here, and we can actually connect this to form a right triangle, which is going to be awesome. And basically what this question wants to know here, and I'm going to do this in a different color, is our angle theta, and that'll be right in there. So from here's your observer, and it's going to call him an obs, and this is where the plane is. So one thing that you guys here will notice is that this is a right triangle. So we can use our SOHCAHTOA, or here we're just going to use our tan equation. So that is where tan of theta is equal to your opposite divided by your adjacent. So here's your opposite. And this one here is your adjacent. Okay, so now I'm going to quickly go back to our Word document, and I'm just going to quickly type in this equation. So we have the tan of theta, or I'm just going to say tan of x, and that is equal to your opposite divided by your adjacent. Here we're only really given what our adjacent is. So I'm just going to jump on down here. So we have the tan of x is equal to your opposite, which would just be, we'll let that be d. And that is divided by 6,000 meters. And we'll just write that as 6,000. And what we're trying to look here for is that value d. So I'm going to isolate for d to make this equation. So we can say that's 6,000 times tan of x. And we're multiplying because In this equation up above, it was dividing, so we want to move to the other side, so we do the opposite operation, which is multiplication. So we have 6,000 tan of x is equal to d. So right there this is the relationship between the horizontal distance, that'd be your d, and the angle in degrees formed from the vertical to the plane. So now for b, we need to sketch the function. I'm just going to quickly switch over to Paint here. To graph tan, we don't need to go into a whole lot of detail. Really, realistically, we wouldn't go over 135 degrees, or else that would not make a right triangle. So we just need to basically find those first two, or those little middle values in between, let's say 90 degrees and negative 90 degrees. That's where your asymptotes are going to be. Remember, with your original tangent function, that's pi over 2, and pi over 2 is equal to 90 degrees. So if we can find those values in between negative 90 degrees and 90 degrees, we should be good to go. Yeah, you wouldn't want to go any other angle bigger, or else we're going to be getting into obtuse triangles, and that is that's not a right triangle. So we're kind of getting away from the point of what we're trying to look for. Okay, so let's start by plugging in some values here. So we're going to start at when we plug negative 90 degrees in for x. What we should find here is that your y value here will be undefined. I kind of already talked about that. That is where our vertical asymptotes are. Our next one that we can plug into our calculators is 45 degrees. And when you ladies plug that into your calculators, you should come out with the value of negative 6,000. Okay, so our next one will be at 0 degrees. And this one is at our tangent function goes through the origin here, so this will be at 0, 0. And we'll do 45 degrees. And plugging that into your calculator, you should get 6,000 for that value. And when you plug in 90 degrees, if you ladies can take a guess here, should follow the same pattern. So it should be undefined when you insert 90 degrees for x. Okay, so now let's graph this. So first of all, to start, I'm going to put in, I guess we're going to label the spacing for our graphing here. So we can go by, let's go by 45 degrees every 2 tick marks. That would work too. Alright, so our 90 degrees is, maybe I should clarify, I'm not the best with Paint, especially with my wireless mouse. It's not really the most fantastic. Here we'll have negative 45 and negative 90 degrees there. There's no point in going any further because we're not going to be using those values anyways. Alright, so for our y-axis, every 2 lines I'm going to go by 3,000. Oh boy, I sure hope you guys do a better job than I'm doing right now. And this here will be 6,000. If you want to label the whole thing, I'm not really concerned if you guys, as long as you get your main ones in there. And then our bottom here will be negative 3,000 and negative 6,000. Alright, that looks super duper sloppy, but I guess that'll be alright for now. Okay, so to graph, I'm just going to choose, I chose a different color here. And so our first value here is at, I guess we have an asymptote, so I'm just going to pull out a little line here. So to denote your vertical asymptote, you usually do a dotted line. I don't think Paint does dotted lines, so I'm just going to draw a line here to indicate the vertical asymptote. Make sure you guys put some arrows on those ends to show that your asymptotes can keep on going. Alright, and then our other one was at 90 degrees there. Alright, then our next point we had at negative 45 degrees and negative 6,000. That's approximately right there. I should grab my little, switch out of my little line so I can grab a little point. And then our next point was at 0, 0, and then we're at 45 and 6,000. And you guys can double check this using your graphing calculators. You know, me and Paint, we're gonna make this fantastic graph, if you guys can imagine that. So connecting those points, your tangent kind of follows that same pattern, so it should look something along the lines like this, sort of. Except hopefully yours will look a lot nicer.